Welcome, cosmic explorers, to Cosmic Conversations, the podcast where we dive deep into the most mind-bending topics our universe has to offer. I'm Anna, and joining me today is my co-pilot in cosmic curiosity, Alex.
Thanks, Anna. It's great to be here. And today, we've got an absolutely jam-packed episode lined up that will take us from the very beginning of everything to the furthest reaches of space and time.
We're going to start off with a bang, literally. But first, a quick glimpse at what's coming up.
Today, we'll be starting our journey by peeking through the eyes of giant telescopes, wrestling with the grand narrative of the Big Bang Theory, and attempting to measure the unfathomable distance to galaxies and stars.
So, settle in, grab your favorite space-themed beverage, because we're about to embark on an incredible journey. The universe, in all its complexity and beauty, is a constant source of wonder and scientific inquiry.
Absolutely. From the smallest particles to the largest structures, there's always something new to learn, something new to question. Today, we're going to explore some of the biggest questions humanity has ever asked, guided by the incredible progress of modern astronomy and physics.
And speaking of progress, let's kick things off with the very tools that allow us to peer into the cosmos: telescopes. Alex, can you imagine trying to understand a painting without being able to see it clearly?
That's such a great analogy, Anna, because that's what observing the universe would be like without these incredible instruments. From Galileo's first crude spyglass to the Hubble Space Telescope, and now the magnificent James Webb Space Telescope, each technological leap has opened up entirely new vistas.
It's not just about big lenses anymore, is it? These are sophisticated observatories, some looking in visible light, others in infrared, X-ray, or radio waves, each revealing a different facet of the universe. Without them, much of what we know about the universe would remain a mystery.
And what they've shown us has led to our current understanding of the universe's origin, the Big Bang Theory. Anna, when people hear Big Bang, they often picture an explosion, right?
They totally do, Alex. But it's important to clarify, it wasn't an explosion in space, but rather an expansion of space itself. This theory postulates that the universe began from an extremely hot, dense state about 13.8 billion years ago and has been expanding and cooling ever since. The evidence is solid, from the cosmic microwave background radiation to the redshift of distant galaxies.
It's a truly humbling concept, isn't it? To think that everything we see, everything we are, originated from a single point in time. Mind-blowing. And speaking of distance,
When we talk about galaxies moving away, it brings us to a concept that's almost impossible for our human brains to fully grasp: the sheer distance to galaxies and stars. Our everyday measurements of meters or kilometers are utterly useless here.
you're so right. We're talking light years, parsecs, and megaparsecs. To put it in perspective, a light year is the distance light travels in one Earth year. That's about 9.46 trillion kilometers.
And that's just for stars. The nearest star to our sun, Proxima Centauri, is over 4 light years away. And galaxies? The Andromeda Galaxy, our nearest large galactic neighbor, is a staggering 2.5 million light years away. These unfathomable distances are a constant reminder of the immense scale of the cosmos.
The search for extraterrestrial intelligence, or SETI, has been scanning the skies for decades. From simple microbial life to advanced civilizations, the possibilities are endless. And within these vast distances, lurking in the darkness, are some of the most bizarre and powerful objects in the universe: black holes. Anna, these aren't just empty spaces, are they?
No, definitely not. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. They form from the remnants of massive stars that have collapsed under their own gravity, or as supermassive black holes at the centers of galaxies.
The concept of a singularity, an event horizon, and the way they warp spacetime are straight out of science fiction. Yet they are very real, confirmed by gravitational wave detection and direct imaging. They are truly the ultimate cosmic vacuum cleaners.
Speaking of stars, not all stellar formations are destined for a glorious life of fusion. Let's talk about failed stars and nuclear fusion. Alex, how do stars like our sun actually generate energy?
Our sun, and indeed most stars, generate energy through nuclear fusion, fusing hydrogen into helium in their cores. This process releases immense amounts of energy, which is why stars shine.
But sometimes a cloud of gas and dust isn't massive enough to ignite sustained nuclear fusion. These failed stars are called brown dwarfs.
They're too big to be planets, but too small to be stars, glowing faintly from residual heat. They're a fascinating example of the delicate balance of forces required for a celestial body to become a true star. It's like nature's cosmic almost there. Seen. Now let's shift gears from the very real to the realm of theoretical physics and pure speculation, but speculation rooted in our understanding of the universe. Time travel. Anna, this is a classic sci-fi trope, but what does actual physics say?
It's such a fun one. The concept of moving through time, either to the past or the future, is a staple of science fiction. Einstein's theory of relativity suggests that time is not absolute, but relative, and that massive objects can warp space-time.
This leads to ideas like time dilation, where time can pass differently for observers moving at different speeds or in different gravitational fields.
While traveling to the past presents significant paradoxes, think about Back to the Future. Traveling to the future is, in a theoretical sense, possible, albeit at speeds close to light or near massive gravitational sources. Will we ever build a time machine? The jury's still out, but the physics is certainly intriguing. From the theoretical to the existential, aliens. Alex, are we alone in the universe? This is perhaps one of humanity's oldest and most profound questions.
It absolutely is. With billions of galaxies, each containing billions of stars and many of those stars likely having planets, the statistical probability of life existing elsewhere seems incredibly high. And then there's the Fermi paradox, which asks why, if alien life is so probable, we haven't found any evidence yet. It only deepens the mystery. What do you think, Anna? Are they out there watching us, or are we truly unique? Let's pull back and look at the grand structures of the universe again. Galaxies and dark matter. Anna, galaxies are immense collections of stars, gas, dust, and dark matter, held together by gravity.
Our own Milky Way is just one of billions. But here's the kicker. When astronomers calculated the gravitational forces needed to hold these galaxies together, they found something startling. There wasn't enough visible matter.
This led to the hypothesis of dark matter, a mysterious substance that doesn't emit or interact with light, but whose gravitational effects are clearly evident.
Dark matter is thought to make up about 27% of the universe, compared to the mere 5% of normal matter that we can see. It's one of the biggest enigmas in modern cosmology, and understanding it is key to unlocking the universe's ultimate fate. It's truly a cosmic puzzle. And if dark matter wasn't mind-bending enough, let's plunge into the deepest conceptual waters with the multiverse and quantum mechanics. Alex, tell us a bit about why quantum mechanics gets so strange.
Quantum mechanics describes the behavior of matter and energy at the atomic and subatomic levels, where things get incredibly bizarre. Particles can be in multiple places at once, and observation seems to affect reality.
This has led to various interpretations, including the many worlds interpretation, which suggests that every quantum possibility actually occurs, splitting our universe into an infinite number of parallel universes, a multiverse.
Could there be other versions of you living different lives in alternate realities? It's a truly wild idea, pushing the boundaries of what we understand about existence itself. It's the ultimate what-if scenario. As you can tell, Anna, many of these concepts, black holes, time travel, aliens, multiverses, have been fertile ground for storytellers.
Absolutely. And that brings us to our final point, sci-fi movies and series. From Star Wars and Star Trek to Interstellar and Arrival, science fiction has not only entertained us, but also inspired generations of scientists and thinkers.
These narratives allow us to explore the implications of these cosmic ideas, pushing the boundaries of our imagination and making the seemingly abstract concepts of physics and astronomy accessible and thrilling.
They show us what might be possible and perhaps what we should strive for or avoid. They're like our cosmic dream machines. Alex.
And that, my friends, brings us to the end of another cosmic journey. We've covered a lot of ground today, from the infinitesimal to the infinite, from the past to potential futures.
The universe truly is a remarkable place, full of mysteries waiting to be solved. Thank you for joining us on Cosmic Conversations. We'll be back next time with more mind-expanding topics.
Until then, keep looking up.